Hello, everyone. I think we already doubled participation this week. But anyway, let's wait for another minute or so. Maybe somebody else wants to join. And those of you who are there, you can already start writing questions in the Q&A panel. Or if you like, of course, you can also just ask directly if you have questions. And I got to ask my team, were there any Stack Exchange questions that we should answer? Or
I think not.
Okay, good. Right, then we just see whether somebody from the participants has questions, and then we can try to answer them live. Yeah, so feel free to type your questions in the Q&A panel or ask them directly if you prefer. And seeing as there are so few, it's a good opportunity to also ask more elaborate questions that take more time to answer. Somebody rose their hand. I just don't know. Somehow when I click on that, nothing happens. I mean, I see one attendee has a hand raised.
Can you hear me?
Yes.
Hello. Okay. Hi, everyone.
Hi.
I have a question regarding the last lecture regarding staking and Plutus. When we transferred funds, when we specified the change to go from the user to the script that we wrote with the validator. After that, I was wondering if there's any way to get these funds back, because if I understood correctly in the validator, the certification and the rewards only return true when the conditions are met, but then anything else returns false. So I was wondering if we can just create a simple transaction that lets the validator just unlock these funds to get them back.
Well, so it's important to keep in mind that, I mean, the nature of Cardano address is that it's these pairs, payment part and staking part. And so there's always a payment part and the staking part is optional. And all I did in basically everything I said in the last lecture was only about the staking part. So the script we wrote only concerns the staking part. So everything payment related was not touched by that. And this change address, I kept the old change. I mean, originally, there were these users created by the private testnet, and they both had payment and staking part, and both parts were given by key pairs. And then this new address that I used as change address, I kept the payment part, and I only changed the staking part, and I swapped out the original key pair with the script I wrote. So the payment part is responsible for who can spend the money. So because I kept that, the same person that it belonged to before it still belongs to that person. So that was this user one or the two, user one, I think. So it never left him. He can always spend it freely by just signing with his key, the old key. So that has nothing to do with Plutus. So the Plutus thing was only regarding staking issues. And so there are only things that involve staking, and that's basically everything having to do with certificates, registering certificate, changing delegation and unregistering, and withdrawing rewards. So only for that, these conditions have to be met. And as you said, to keep it simple for the certificate stuff, I returned true anyway, I think. Yes. So that was all fine. So the only thing there was any condition was on the withdrawal of rewards. But that's only the staking part. So the payment part, the same user one as before can freely send the money anywhere. So there's no need for him to get it back. Because it never left his wallet basically. But he could easily create a transaction that takes the money and sends it back to the other address, to his original address. Does that answer the question?
Yes, absolutely. That makes a lot of sense. So we basically just separated the staking account, but the payment signing key was still the same.
Exactly. And okay, both, nice. Yes. And both parts, So it's, I mean, there are lots of combinations. I think, I don't know, 10 or so. I mean, so first of all, there's a payment part and the staking part, and the staking part is optional. And then both of these parts can either be given by keys or by a Pluto script. And all combinations are possible. So in this example, we had where the payment part was given by keys and the staking part was a Pluto script. And in the previous lectures, we mostly talked about where there was no staking part and where the payment part was given by Pluto script, by a validator. So in that case, the logic of the Pluto's contract determines who can spend these UTXOs that sit there. But yeah, so this was, yeah, so there are lots of combinations, key, script, key, script, and then optional. So I don't know, 4, 6 or something, different types of addresses. And yeah, and this is an interesting, so basically, yeah, the payment part, the owner of the money never changed, just what the staking related stuff. I mean, one can think of, I mean, I always, some talks I gave, try to explain Cardano. I mean, the point is that ADA has this dual nature. It can be used as like payment, but it's also used to basically cast your vote on the blockchain to participate in consensus. And these two natures can be, they are basically split. So, and this is exactly reflected in this dual nature of the address. So whoever is in control of the payment part has this spending power, can use it as money. And the other part is basically the voting power on the blockchain, which also then entails getting rewards. And that's actually quite interesting. I mean, I think in some contexts, these addresses are called Frankenstein addresses or so. I think some wallets like Eternal also even allow you to create them. Where you, I mean, the normal cases, if you have a wallet, you don't have to worry about any of that, and you get a payment and staking part are both given by keys, and those keys are in control of your wallet. And I mean, you don't even realize that sometimes you sign with the one and sometimes with the other because you just enter your password and the wallet takes care of everything. But I mean, for example, somebody could send you money to your payment part, but like sneakily set the staking part so that it's like his own staking key. And then, I mean, it's your money, you have it in your wallet, but he would get the rewards for it, staking rewards. So I mean, one must be a bit careful there. But on the other hand, it also has like very nice opportunities that haven't been fully used yet. I mean, for example, if you have some smart contract like a DEX or whatever, where or staking, no, not staking maybe, but anything where ADA sits for a long time, for example, liquidity in the DEX, then I mean all the functionality of the DEX is concerned by the payment part. So there's a complicated smart contract that determines under which conditions that can be spent, and I mean whatever. But the staking part is completely, I mean, it's like orthogonal to that. So it's definitely possible that you have like some smart contract as payment part, but then as staking part, you use your own staking keys. And that means even though you send your money to the smart contract to participate, for example, in a DEX, the ADA in there can still contribute to your rewards. So you basically don't have to decide, either you stake it, leave it in your wallet, or you participate in some sort of smart contract DEX or whatever. So that's actually quite nice. And you don't have to do anything for that to happen in Cardano. That's automatically built in. But I think very few projects make use of that yet. But I mean, it's certainly possible, all sorts of these interesting combinations. Right. Does anybody else have a question? Okay, there's nothing in the, oh yeah, there's one in the panel. Let me see. 2 questions. Wow. Why there is some smart contracts like minting or staking script that doesn't need datum? I can't exactly grasp the difference between datum and redeemer. Okay, so basically I mean, what you first have, before you talk about smart contracts, you first have, Pluto's first have to understand where the datum actually sits. And the datum is a part of an output. So you have this transaction, it's, I mean, this blob with inputs and outputs. And the outputs have datum. So each output potentially can have a datum. It doesn't have to, but it can have. So datum is something that's associated with an output. And therefore, if we talk about scripts, I mean, it only makes sense to have a datum involved if, I mean, the most common scripts that we talked about are these validators, the spending validators, where you want to spend a given UTXO. And that, I mean, UTXOs, as I just said, they have datums. So then, I mean, if you want to spend it, the script needs all the information about this UTXO, and part of the information about the UTXO is its datum. I mean, it's its value. It's basically UTXO is given by three things: the address, the value, and the datum. And as a consequence, the Pluto script that like involves or is about whether an UTXO can be spent or not gets those pieces of information, particularly the value and the datum. I mean, it itself is the address. But I mean, minting and whatever staking wouldn't make sense because there is no, what datum would you use? I mean, the datums only sit at the outputs. And well, that's also the difference between datum and redeemer. I mean, datum sits at the output and redeemer sits at the input. So datum is something that's under the control of whoever created the UTXO, and redeemer is something that's provided by whoever wants to spend the UTXO. So it's like, I mean, some people say the datum is like a lock and the redeemer is the key. I'm not sure that's so. I mean, normally it's not used in that way, but that's one way to think about it, I suppose. But in any case, so I mean, the one is the responsible. I mean, whoever creates the UTXO, he has to decide what datum to use, and whoever spends the UTXO, he has to decide on the redeemer. So there, it's two different roles. It's two different people normally. So that's the difference. It is true, of course, that often you have a lot of choice how you actually design your smart contract, and sometimes you can. I mean, I can understand that it's somewhat confusing because often, basically, a certain piece of information that you need can be in the datum or in the redeemer. It's not so clear sometimes. But I mean, in principle, there's a very clear distinction. The datum sits at outputs, and the redeemer is a part of the input. The datum is provided by the transaction that puts it there, and the redeemer is provided by the transaction that spends the UTXO. I hope that answers that. It's another question. Hey all, could please describe a bit when, how a signing happens with pubkey hashes during the transactions? In the homework, I guess it is somewhat the same as it was at week 3, where we had beneficiaries to sign. For example, let's say we have the staking example in the homework where we want to restrict the withdrawal. Do both transactions should be signed, meaning during the staking transaction and also during the withdrawal? Thank you. I'm not sure I completely understand, because I mean, there's only one transaction, right? I mean, what's the difference? But I mean, signing, I mean, transactions are signed. So, I mean, signing happens when you create a transaction, or to be more precise, normally you first create an unsigned transaction, then you sign it, and then you submit it. So that should answer the first part. So in the life cycle of transaction, I mean, you first build it, then you sign it, and then you submit it. And I mean, which signatures are needed depends on the transaction. So, I mean, the most common case is that you spend some UTXOs that belong to somebody, I mean, to you normally, and then you have to sign the transaction to spend your UTXOs. If you want to spend somebody else's UTXO, that somebody else would also need to sign. And now if staking is involved, for example, if you want to withdraw staking rewards, then and if the staking of a certain staking address, and if that staking address is given by a key pair, then the owner of that key pair also needs to sign. And if it's, as I just explained before, so there are like payment part, staking part, and both can be given by keys or by scripts. So whenever in a whenever a transaction involves payment part or staking part given by keys, then the owner of that key has to sign. So for the payment part, that's if you want to spend a UTXO, that sits at an address that's given by keys. And for staking, it means if you do a staking related thing in your transaction, like registering, deregistering, or changing delegation or withdrawing rewards. So in any of those four, if you do one or more of those four things in a transaction, and if it involves a staking address that's given by keys, then that has to sign. And if you spend UTXOs and any of those sits at an address where the payment part is given by a key or keys, then the owners of those keys have to sign. And normally, of course, in 99% of the cases, it's always you. I mean, it's your staking key and your UTXOs, and you sign. But it doesn't have to be. And I'm not really sure I do understand the second part, so maybe you can clarify a bit what you mean by during the staking transaction, also during the withdrawal. I don't understand what the staking transaction is. I mean, there's one transaction that does the withdrawal. Right. So maybe you can clarify if you're not happy with my answer. Okay. I think Adam, I think, do you want to? Yeah, you raised your hand. Can you hear? You want to speak up?
Hey, could you hear me?
Yes.
Thanks. So yeah, maybe I'm mixing up things a little bit with this staking and also the withdrawal transactions. So I just meant that, for example, yeah, I have to make transaction first, as I understand, to set something as staked, let's say, and then is it another transaction when I withdraw the same funds, or am I completely wrong?
I mean, what you withdraw are your staking rewards, and the staking rewards, they accumulate over time if you have ADA sitting at a certain staking address. So, I mean, first, of course, some ADA must get to the staking address. So, I mean, in the example that Albert was asking about, I mean, first, I had my test ADA was sitting at these test users and then I created this staking address given by a script, and then first transaction I did was send the money from the old address to the new address where the payment part is the same, but the staking part is now given by the script. So yeah, that's the first. So at that moment, I mean, before the ADA had basically accumulated rewards at the staking address given by the user one keys that the private testnet defined. And after the transaction, they still belong to user one, but now the staking address had changed. It used to be the one given by the key pair, and now it was the one given by my script. So from that time on, every epoch, the money sits there at the staking address, it accumulates rewards. And if you want to withdraw the rewards, you need a transaction. So that's this withdrawal transaction. And yeah, so therefore I did a second transaction, which basically didn't shift any funds. I mean, I left the money that was sitting there where it was, I think, but I did collect the rewards, and then I had to pay in order to make the contract happy. I had to pay half of it to this other user and pay half of it to myself.
Okay, yeah, I think I got it. Thanks.
Okay, very welcome. Okay. Hello, do Pluto's staking functionalities apply also to other native Cardano tokens? Thank you. No, they don't. In a lot of regards, ADA and native tokens are interchangeable, basically. So in a certain sense, that they are no different from each other, but in this sense, they are different. So the staking is only about ADA. That being said, I think there were some, at least, plans or proposals to change that. I mean, there's this Babel fee. I'm not sure whether it's related, but I mean, there was an idea or proposal, I think it's called Babel fees, that you can pay transaction fees not only in ADA, but also in other tokens. And I don't know exactly how it works, but I could imagine that something similar could be done for staking, but at least at the moment, the answer is only Ada. Therefore, projects on Cardano, I mean, normally every project has their own token, and they all, I mean, a lot of them offer something they call staking, but that's then different. That's not the built-in Cardano staking that automatically happens with Ada. I mean, then those projects have to do something. So normally they create a smart contract where people lock their tokens and then they get some sort of rewards. But that's different. You have to explicitly do that. It's not built into Cardano. There's various kinds of data on Plutus, like data, built-in, etc. Which purposes does those types have? Does those types of data correspond to different steps of compilation process from Plutus, Plutus Core, Plutus Script? Not completely sure what you mean by various kinds of data on Plutus. And I don't think it has anything to do with compilation, but I don't really, unfortunately, I'm afraid I don't understand the question. I mean, what types exactly do you mean? I mean, built-in, I mean, there's built-in data. Or do you mean data and built-in data? That's a good question. I think I also don't understand that. And I think nowadays, basically everything is using built-in data. I mean, like in the first iteration I did, built-in data didn't exist and it was just data. And then they somehow introduced built-in data for some reason I never fully understood. And I think now basically nobody is using data anymore. So, but basically built-in data is just like, I mean, I always think of it like JSON, like a universal blob type that can encode everything. But that has nothing to do with compilation, I think. But I mean, it's true that it's a type. I mean, it's a Haskell type that has an equivalent in Plutus Core. So it's basically the data type that Plutus Core uses. So in that sense, maybe. But yeah, I don't know what it's to say. Maybe you can elaborate. Okay, Manuel is happy. Let's see. Hi, I'm not sure this is the right place to ask such a question, but I'll try. Could you explain the recruitment process in terms? And the second question, I'm a fan of Haskell. Do you have a separate Haskell team? And can I get into this team in the future? Thank you. Are you referring to the recruitment process for IOG, I suppose, or for not for the Plutus Pioneer program, right? Because the Plutus Pioneer program, in principle, whoever wants to learn Plutus is welcome. I mean, I'm not intimately familiar with the recruitment process, but it's like, I mean, normal. I mean, you apply by email or clicking on some link, and then you get invited. I mean, you send your CV and you get invited to various interviews. And somehow over the years, it seems to be more and more interviews. But I mean, like at any other company, really. And yeah. And yes, we do have a Haskell. I mean, I'm not sure whether we have a team that's just called Haskell team, but I mean, some of our core engineering teams use Haskell, like the Node team and the Plutus team. And so we do have teams of engineers that use Haskell. And sure, you can. I mean, if you know Haskell, actually, we always, I mean, normally we are always looking for Haskell developers. So there should always be openings. You can just apply. I mean, I don't know. I don't keep track of what exactly is open right now, but probably even now there's like opening for Haskell developers. Yeah. So I mean, there's nothing special about our recruitment process. It's just apply and then get invited to interviews. Oh yeah, actually there is something special. I think if you apply for Haskell position, there's actually a Haskell puzzle basically that you, or not puzzle, like a little homework basically that you are supposed to do. At least some teams use that. And I think different teams use different ones. You're welcome. Are there any other questions? So please feel free to ask whatever you like.
Roberto is with the hand raised.
Ah, right. Please go ahead, Roberto, if you have a question. Do I have no?
Hi, I'm not sure if you were referring to me.
Yeah,
Yeah.
I
it
had my
looks
hand
as if
raised.
your hand is raised or something.
Yes,
but-
yes. It's just that you called me Alberto. I usually
I
used
think
to
he said
Alberto.
Roberto, but anyway.
Yeah.
No, it was Roberto, but he said it was a mistake. So it's now.
Oh, okay.
Yeah.
That's the confusion. All right. Well, if there's no more questions, maybe I'll ask about a bug that I have. Use this opportunity to maybe get some pointers for the homework for the staking and Plutus lecture. When I build a transaction, I'm getting the missing. So I did the homework and I added the requirement for the PubKey hash to be of the user one. Let's say if it's user one that's created the validator, but then at the step of building the transaction, I get an error saying that the signature is missing, and that's a little confusing to me because I would assume that the transaction would happen at the signing, the signing and the verification would happen at the signing stage, not at the building stage. So I'm sure I'm missing something, but I'm not exactly sure what.
I'm not completely sure. I think you have to. Can you say must be? I mean, I know in Plutus it says something like must be signed by. Can somebody help me out here quickly?
Yeah,
Thomas. Go ahead.
yeah, I think that what happens is when you create a transaction, it's fully deterministic. So before you sign, it's checked. So if you need a signature, it's invalid if it's not there. But if you add like the specification that it needs a signature of a certain particular key, then that is, the check is omitted that it's not there in that sense. And then your wallet can sign it and check it again, for example.
Right. So you have to explicitly say when you build the transaction that a specific signature has to be included, right? But
Yeah.
you don't have to say that if you spend a UTXO, then it's somehow implicit.
Yeah.
Right. Yes. So because your script now requires the presence of a certain signature, when you do this transaction build command, there's some option to say signed by PubKey hash. And that is then checked. And then later when you submit it, of course, it's checked that the signature is actually there. I mean, you have to sign it if you, but as Thomas said, so even before you sign it, the transaction is already checked.
Yeah, the Plutus scripts are checked.
The Plutus scripts are checked, exactly. And they basically don't check that the actual signature is there. They only check that the transaction says it will be signed by that person. But then, of course, later, if that person then doesn't sign, then it's also invalid. But then the Plutus script doesn't have to run anymore. So that's how it works. That's why that error already comes up before you sign. Yes.
Okay, I think I understand. That means that there's a parameter, there's an option I have to specify to the build command that lets me tell the validator that I promise that this user will sign it later on, and then it will build. And then when I sign it, if I indeed signed it to the right user, then it will go through, basically.
Basically, yes. I just forgot what that is called.
In week 3 we have that, and in week 9 we'll have like 2 or 3 more examples using that. So.
What tool are you using again?
Yeah.
What tool are you using?
What
Cardano
tool?
CLI?
Yes, Cardano CLI, yes.
Okay.
What is it called there? I forgot. So you have to explicitly give it there, right? I'm not completely sure. I'm just looking at the documentation. Yeah, required signer. There is something called. I can share. I think it's that. Just give me a second. So I just called this this Cardano CLI transaction build command. And if I'm not mistaken, that can be, but I think it's this here. So required signer hash of the verification key 0 more whose signature is required. So we have to specify that. Then this error will get away in the first step before you sign and you build. And then of course if you promise that that person has to sign, then actually you have to include that signature when you sign. Otherwise, if you submit, you get an error.
Thanks.
Welcome. Okay, there was no 4 more. Sorry. How many weeks is this course? Well, 2 more. So mine was lecture 8. Now this week lecture 9, and then next week lecture 10, and that's it. I suppose we still do a Q&A after lecture 10. Maybe, I'm not sure. But yeah, but the lectures, 2 more lectures. It's because sometimes I see types like that's okay. It's types like data or built-in data and functions that transforms those data to another. So at first I got confused by this and what does this type mean? I must admit I also get confused by that. I never fully understood the difference between data. As I said, in the beginning there was only data. Then they introduced built-in data, and now it seems you never use, or I at least never use data anymore. So I'm not really sure what data is good for. I think it's more a historical artifact. But it has nothing to do with compilation pipelines. I don't know. There was, but there is some help in the. If you look at the documentation, they do explain somehow what's supposed to be the difference.
I'm reading the documentation here, and
Yeah.
it says in the type that the point of built-in data is to be an opaque equivalent of data to ensure that it's only used in ways the compiler can handle. It's kind of the same, but safer.
Whatever that means. I mean, I'm not really sure. Yeah, whatever. Yes, that's what I mean. That's what they say. Yeah, I must confess I never really understood exactly what they mean by that. But it's sort of, I mean, I think what they mean is, I mean, whatever. I mean, I don't know what data is really, what the difference is. But I mean, built-in data is like the built-in, I mean, it's, as the name suggests, it's the built-in like hardware types of Pluto's core. So those types are built in. That's why it's built-in data. Yeah, so that's like the data type that Pluto's core understands. Right, but yeah, as I said, I think I've never used data anymore recently. I mean, the last year or so. So probably one should just get rid of it. It's actually a good point. Next time I talk to the Plutus people, I should ask about that. Because it's just confusing anyway. Yeah, there's no, yeah, nothing to do with compilation pipelines, I think. Yeah, exactly. Require signer hash or require signer key. I think pipeline must be used instead of pubkey hash. Yeah, that's also a bit confusing, right? I mean, at some point in Plutus, in like second iteration or so, they changed. I mean, it used to be called pubkey hash, and then at some point they called it payment pubkey. Or was just pubkey, then they called it payment pubkey, and now they don't call it payment anymore. It's back to pubkey, and maybe the CLI still calls it payment. And I don't even actually know whether technically these keys are different. I mean, the staking keys and the payment keys, or are they technically just exactly the same encryption scheme and everything? It's just the use for what they are used. I mean, could I use a payment key and as a staking key basically? Not sure. But yeah, I mean, whatever. I mean, they mean, although I'm not sure. I mean, if it's, that's a good question. So yeah.
I think they use the same signature scheme. So that's Edward 25519. But they're serialized in a different way in the envelope. That's the main difference. And I think it's called a payment pub key because it needs to be different from all the other public keys that we have. For example, the VRF that pool operators use,
Right, right.
and those keys.
Yes, and this Cardano CLI argument or parameter we just looked at, this required signer key, I assume that applies to both staking key and payment key. I mean, if in this example, like in the homework example, I suppose you would use that as well, right? I mean, if you have to sign for the staking key, or if you want to withdraw, yeah. I mean, it's a good
I'm not
question.
sure,
Actually.
but I never tested it, but I think it's the same because if you look at where the signatures are added, that's just a witness, and
Mhm.
both will be in the same place. So I think it should go through fine if you add it there for the staking.
I've
part.
also never tested that, and yeah, it should just be that required signer key, and that should work both for like spending scripts and also for staking scripts that somehow require a signature. Yeah. And I think I mean, in Plutus, there's no such thing as payment pub key hash anymore. I think it used to be there at some point, but now it's just pub key hash. Yeah. Okay, there was some. Okay. Are there any more questions? I see one raised hand, but that's still Albert, I think, from the beginning.
Yes, sorry.
No problem. Just wanted to make sure you don't have another question. I mean, if you have, it's fine, of course. Okay. It's nice that this time we had more questions again. So yeah, if any of you, we still have 20 minutes. If anybody has other questions, please feel free. Otherwise, we can talk again next week. Okay, and thank you for.
Lars, wait,
Yeah.
Agustin has another question, I think.
Okay. Please go ahead.
Agustin? You're muted.
Ahora,
Yeah, okay.
do you hear me?
Yeah, yeah.
Yes.
Okay, thanks. I have a question regarding the first question that I did on Datum and Redeemer. So
Yes.
from what I understood, Datum are related to output and Redeemer to inputs, right?
Right. Yes.
And so we can say that Datum across transactions can transport state. Sorry, my English, but
Oh, it's fine. It's fine.
So Datum, you can use Datum to carry a state across transactions, right?
Yeah. Yes.
And Redeemer to like inject new information. So that's what I understood from your answer, your latest answer.
I mean, somehow
maybe
it's. Go ahead. Sorry.
Maybe can you explain a little bit more about it because I couldn't grasp completely the.
I mean, in principle, it's just available. I mean, what I mean by that is how you use it somehow depends a bit on your use case, I suppose. I mean, often, for example, Redeemer is not used. I mean, I think originally Redeemer is really in the sense of key. I mean, the idea is that, I mean, before smart contracts, you have to sign a transaction. So basically by providing your secret key, you can unlock a UTXO. So it's this lock and key thing. And now one way to look at at the extended UTXO model is that instead of having to sign, you provide a redeemer. So the redeemer is in that sense, it's like a generalized key. But I think mostly it's not used that way. It's more like, maybe action would be a better name than redeemer, because often you have like different types of things you can do with a UTXO. For example, I don't know whether we had an example, but for example, in my vesting, no, that's maybe a bad example. For example, if you have a DEX and an order, then you place one sort of tokens in a smart contract UTXO and specify a price in the datum that you want in exchange for whatever. Let's say you want to change, I don't know, ADA for gens. So then you say, okay, here 1,000 ADA, I place them in this UTXO, and I want whatever 2,000 gens for this. And okay, and then normally there are then two things that can potentially happen. One is that somebody is willing to pay the 2,000 gens to you, but it could also be that nobody is willing to pay that and you want your money back. So that's like two different types of things two different types of transactions or that can happen with this UTXO. And in that case, it would be quite natural to have a redeemer that is just an enumeration type and has like fill and cancel. So if you provide the fill redeemer, that would be used by somebody that wants to actually fill the transaction, pay the price. So then in that case, the validator would check that you pay the specified price, the 2,000 gens to you, and for that you can take the 1,000 ADA. Or if it's the cancel redeemer, then basically it checks that you sign it, because obviously only you are allowed to cancel your own order. So that's actually, I think, the more typical use of the redeemer. There are various examples where certain actions are possible. Like for example, with an Oracle UTXO, one action could be to use the Oracle and one could be to update the Oracle value. So then you would have like these two possible redeemer values, use and update. So I think that's how people normally use it. Not so, but what you said to provide more information, that's also possible, of course. I think, I didn't do it like that, but like 2 years ago or so when Alonso started, I had this lobster challenge thing where Charles Toy Lobster was supposed to get a name. So I didn't do it like this because there was something not working with Plutus. I couldn't do it like that, but I would have done it. I would have done it like this. So the idea was there that the datum carries some like a random number, and then people can influence that. So people can issue transactions and add, I think the number was, I don't know, I forgot, but let's say there were 600 potential names for the lobster. And then the idea was that there's this UTXO and there's in the datum is just basically an index number between 0 and 599. And then people can like change that number by adding or subtracting something between, I don't know, -20 and 20 or so. So I didn't, as I said, I didn't do it like this for technical reasons, but if I had to do this today, I would use the datum for the current number, and then the redeemer would also be of type integer, and that would then be added or subtracted from the current value. So you would consume the UTXO, add the redeemer value to the current datum value, and then the new datum would be the sum. That's exactly what you said, or at least how I understood you now, basically that the redeemer provides information. So yes, so the answer is it's not, it's basically up to you. Sometimes it's used like what you said, sometimes it's more used to choose one of potential choices of what can happen next, like this cancel or fill example. Sometimes it's used really like a key. So it could be some sort of secret. For example, I think the very first example the Plutus team had for a smart contract was this guessing game, where the datum is the hash of a secret word, and you basically win by in the redeemer guessing the correct word, and then the validator checks that the redeemer word, if you hash it, actually equals the hash in the datum. So that would be this key use, that the redeemer is like a key. So my point is, it's sort of, I mean, it's up to you sort of how you use it. You can use it as like a choice of action. You can use it like information update, like you said, or you can also use it like a key in some sense of key. So it's flexible. I mean, you basically have that at your disposal, and then how you use it for your use case sort of depends. So there's no straight answer to this. There are all these options.
So
Does that make
you
sense?
can promote information or trigger an action with the
Yes.
redeemer.
Yes.
And datum, generally you use it to carry state.
Yes.
So that, yes. But let's hack a bit that. Can I use datum to, in your example of guessing a smart contract, can I use datum to input the guessing name? Let's say I want to do the things different and not use the redeemer, just use the datum. Can I do that to make the input to the guessing name?
Not really, because I mean, in this setup, somebody basically puts money there. I mean, like the prize money, it's locked in this UTXO, and people want to guess the secret, and whoever guesses it gets the money. So in that case, I mean, the UTXO is already there and it contains the money. And now, I mean, somehow you must, I mean, if you play this game and want to get it and guess the secret, then, I mean, you have to, I mean, in a sense, I'm not sure whether it's now confusing. So I think morally the answer is no, but technically the answer is actually yes, because you could also implement. I mean, I think in the first lectures, or I explained that there are 3 different ways to attach datum. One is I mean, no datum at all. That's also possible. Then if you want to attach datum, you can just put the hash in the output, and then the spending transaction has to provide the actual value of the datum. That's the first option. The second option is you put the hash in the output, but the actual value in the transaction already. And the third option, that's you with Vasilis inline datum. So you put the actual datum already in the output. And you could use this first option to do what you said. So then you wouldn't need a redeemer. So you basically in the guessing game, you just put the hash of, I mean, as before, the hash of the secret word in the datum. And then in order to actually spend that, you would need to know the real word. So yes, so in that sense, the answer to your question is yes, you could do that without redeemer. But that is a bit hacky, I think. It's just because of how exactly it works on Cardano. So I'm not sure that's a good answer.
So,
but yeah, technically speaking, you could.
It's a little bit confusing, because I think obviously it's designed to datum to carry state and redeemer to use it like the ways we talk it, but it doesn't enforce you to do like that. So that's why I got a little bit confused. But
yes, that's understandable.
I cannot get it. Yes.
I think the best is just to look at examples. I mean, if you have seen several examples of smart contracts, how they use datum and redeemer, maybe that makes it clearer. Yeah, it's a bit, I don't know I don't know a good analogy. Maybe somebody else has one. But I mean, there's just, yeah, Thomas.
Yeah, I think your analogy with state and like how state propagates is really nice for it. And just to add to it, like it also has to do with costs. So storing something is more expensive than just using it in a transaction. So if you want to make something persistent, you use a datum. While if you want to make something just available in a transaction, you should use the redeemer. And also you should consider, how is data injected? Who does that? For example, for the caching game, you could have done something like make a predetermined minting policy that has the secret incorporated, and it can mint via an address if it spends in a UTXO form an address, and the datum is used as a guess. then you can use the datum as a kind of like a redeemer, right, in this setup. But it's really cumbersome because you have to do like 2 transactions, and it's not that cheap to do that because you're also minting something. So like how you manage your data and how you structure it, yeah, that's up to you, the developer, and there are multiple ways to do that. And I think the things you should consider is like who injects data, who should I trust with that data, and yeah, costs, of course. And I think the thing that you said, to reiterate, like see it as state and see the redeemer as a data you inject in a transaction, that's perfectly fine.
Thank you. I will experiment with this thing to see how to fully understand. But thank you for your answers.
Very welcome. Okay, I see there's 2 more questions. Will we mint our own certificate as NFT on production system? Actually, probably the answer is yes, but that's not finally decided yet. But yeah, I mean, there's a very good chance for that actually. At the end of the course, as a successful, yes, exactly. I mean, I don't know what we should say about that now, but at least we are thinking about something to get certificates this time. And then it would indeed maybe boil down to that you mint your own somehow. But we haven't finalized that yet. Okay, any other questions?
Professor, if you know the link of that guessing of name smart contract that you mentioned, can someone of the team provide the link to study it or look at it?
Always used to be like the very first example in the tutorial. I don't know. Does anybody have the link maybe?
Yeah, I think it's best known under like 42, right? The guessing game. That's the one you mean, right? Like
No, I don't. It's not 42. I think.
yeah, that's what we most commonly use in examples. I mean,
okay, it was a. I mean, it was just a hash byte string, and then
Yeah,
the
no,
datum.
but 42 was hard coded. I think the ones Lars says was in the datum, like
Yes, it was in the datum. And I don't know whether they changed it, but it used to be like in the Plutus documentation, the very first example. That's the second. Second. It was also there were these Plutus use cases. Do they still exist? It was one.
I saw them recently, but
Yeah, I have them right now. But maybe they don't have it anymore there. Now they have Oracle, DEX, Lending. It seems they upgraded their use cases.
Sengun just share the lobster
Ah.
challenge link in if you want.
But there, the problem there was it wasn't possible to somehow with the Cardano CLI you couldn't really work with datums back then, and therefore I used this trick. Instead of using datum, I used tokens to encode the data basically. So that's a bit misleading maybe. Stupid guessing game. Where was that? Maybe just.
Maybe we can look for it and send it through Discord. Agustin is in
Yes.
Discord. So
Yes, I'm on Discord. So
Where I just Google, there's a Cardano Plutus smart contract guessing game coding tutorial. This is somebody's. Oh, there's Cardano or Cardano. Not sure whether that's the one. I just Googled Cardano, Pluto's guessing game, and there's some YouTube video, but I can't vouch for the quality, of course. But maybe it's that. Yeah, we can try to find out and then post it on Discord or next week in the next Q&A session. Sorry about that. Yeah, it was always the first example, but now they changed it. I think maybe it wasn't a very good example.
Yeah, but wasn't that just the redeemer where everything is set true? Just it validates always, but
No.
the datum that you send is always a hash. So only somebody that knows the hash, that knows the guess, can spend.
Yeah, but you could have done it like that, but it wasn't done like that. It was done with the redeemer. So the redeemer was the byte string, and datum was also a byte string, but datum was a hash. Which is also a byte string, but datum was a hash, and the redeemer was supposed to be the clear text, and then the validator checked that the redeemer hashes to the datum. But it's a bit.
I just a link that I think is that one, but just to host and panelists, because I'm not sure why I don't have the option to share with everyone. You should have chat.
Karina did it.
Awesome, perfect.
Thanks, Karina. Yeah, that's the one. Is it that? No, I think that's a different one, but it doesn't matter. It's similar spirit, I think. This is with numbers, I think.
But I understand it. You put in clear text the answer, and the contract makes hash and checks if the hash is the same from the datum.
Yes.
That's it.
Yes. Thomas's point was just that you don't need the redeemer for that. You could also just use as datum the actual clear text, but then only put the datum hash in the transaction, which is one of the three options how to attach datum. And then in order to spend it, you have to also know the clear text. Yeah, but that's confusing. Like logically what you want is using the redeemer for that. Yes, as you said now. So the datum would be the hash, and the redeemer would be the clear text, and then the validator hashes the redeemer and checks that it's equals the datum.
Cool.
Yes.
Thank you.
Welcome. Okay, any other questions? I'm very proud this time we filled the whole hour. It's good that you had so many questions. That's nice. Okay, then thank you for your questions and take care. Have a nice evening or day, depending where you are, and talk to you next week. Thank you. Bye for now.
Goodbye.
Bye.
Gracias.
Bye.
Muchas gracias.
Thank you.
Adiós.
Bye.